Matrices. All right, what is a matrix? So a matrix is just a set of numbers that we do things with all at the same time. For example, here is a matrix. That's a matrix. So in this case, 6 numbers that we just do things with all at the same time. And we're going to learn to do some arithmetic, different operations, and then we're going to use them to solve some real problems. Yes, occasionally we do actually talk about the real world. What can we say about a matrix? Well, the most important thing here is the size of the matrix. How many numbers have I got? And they're arranged in rows and columns. And we always talk about the rows first, then the columns, always. So if we want to talk about the size of this matrix, the word we actually use is the order. That's the technical name. And the order of this matrix is 2 rows by 3 columns. Notice, always rows first. In fact, that's so important I'm going to write it. Always rows first. Always rows first. Notice the matrix has a capital letter for its name. If I want to talk about a single element inside this matrix, I'm going to use a small letter. For example, individual elements, in this case, little m, 2, 3, means, remember, always row first, row 2, column 3. Row 2, column 3 is 8. Or you might go m, let me go 1, 1. Well, in this case it doesn't matter which order, right? Row 1, column 1 is element 2. Of course, matrices can come in slightly different flavours. So for example, I might have just a single row matrix. That's a set of numbers just in a single row, like that. Or I might have a column matrix. Yes, you can guess what this is going to look like. Let's go. There's a column matrix. Notice all the numbers are in a single column. A lot of the time in this course we'll be talking about square matrices. Square matrices have the same number of rows and columns. Now, if we're going to do things with matrices, probably the most fundamental relationship we're interested in is equality. 2 matrices are equal if and only if they are, I'm going to use the technical word, the same order, okay, same size, and each corresponding element is also equal. Okay, so M and N are equal if and only if they have the same size, same order, and corresponding elements are equal. So for example, suppose I have A being a matrix, what do my notes say here? I'm going to bring it a bit closer to me. For U, the 7, W plus 4, and B is minus 4, 0, minus X, and 1. And I'm going to say if A equals B, calculate U, V, W, and X. So then you go, well, if the 2 matrices are equal, then that means 4U must equal negative 4, which means that U must be negative 1. Likewise, V must equal 0. That one was pretty easy, wasn't it? V equals 0. What else do I know? Third element, 7 must equal negative x. Can I stop highlighting yet? I better keep doing it this first time. So that means x must be negative 7. And finally, the last element, w plus 4 is 1, which means w must be negative 3. So matrices are equal if and only if they have the same order and corresponding elements are also equal. Now, a few names for special kinds of matrices that we're going to see. A square matrix is just a matrix that has the same number of rows and columns. So this one is a 2 by 2 square matrix. You can get a 3 by 3 or a 4 by 4 or an 8 by 8 or however big you want it to be. But square means the same number of rows and columns. We'll be doing a lot with square matrices. A zero matrix, what do you think a zero matrix is? A zero matrix is, of course, just a matrix where all the elements are 0. And again, they can be of different orders. Finally, we are going to talk about identity matrices. An identity matrix fulfills the matrix role of 1 in algebra. So an identity matrix is a square matrix that has 1s down the diagonal and 0s everywhere else. This one's an identity matrix of size 4. Sometimes you might put this one as actually I4. That was messy, let me try that again. I4, because it's an identity matrix of size 4. You don't always need to do that, but the context will make it pretty clear.